Okay, so we are on example 3. Okay. And you can see that there is a distinct change in font, right? So the assignment is out of Delta Math for these. So these are what the problems look like in Delta Math. Okay. So sometimes I'll teach it out of one resource and then I give you the Delta Math and it looks completely different. So I didn't want to leave you guys hanging on that. Okay. So remember our goal yesterday was we talked about using this Lagrange error bound, which is also the remainder of the Taylor polynomial. Okay. So we're trying to gauge how accurate our polynomials are. Okay. All right, so in example 3, we need to determine the degree of the Maclaurin polynomial required for the error in the approximation of the value of cosine of 3 to be less than 0.001 according to Taylor's theorem. Okay, so if we are in Maclaurin polynomial, what does that mean our C value is? So C is equal to 0. We've learned something over the past few days. We've at least learned that, right? C is equal to 0. Okay. Brooklyn's got it down because she answers me every single time. Okay. All right. So we're going to use our formula. Let's refresh our memory on the little formula. Okay. So our formula is whatever the maximum value of the function is, okay, over n minus 1, the first omitted term. Okay. And I can shortcut that. I don't have to do the plus 1 part if I don't want to. Okay. Times x, which is whatever value we're plugging in. Okay. Minus c, which is whatever our c value is, and then to that n minus 1 or n plus 1 term, okay? All right, so we're going to use that remainder theorem. So we write out our absolute value of r sub n of x, because they didn't give me what that value is this time, okay? We want it to be less than or equal to this. All right, what is our function this time? Our function is cosine, okay? What is our maximum value of cosine? Always, what's our maximum value of cosine? Remember we talked about it yesterday? Talked about sine and cosine. What's the biggest I can get on a sine or a cosine?
1.
It's the biggest we can get is 1. Did somebody say that and I just didn't hear it? I'm sorry, I didn't hear it. All right, so this is our cosine max, right? That's the max right there. Max of cosine. Can't get bigger than 1. Okay. Did they give us an n value?
0.001.
Is that an n value? An n value is some kind of exponent. Well, they're actually making us find that, right? Because they're saying determine the degree. So I don't know what the degree is. So I don't know what n plus 1 factorial is, and I don't know what my n plus 1 exponent is here. Okay. But I do know other information. Did they give me an x value that they plugged in?
Mm-hmm.
What is it? 3. Yeah, this is that x value that we're talking about. So they plugged a 3 into it. And then I got to subtract the c value. What's the c value?
0.
0. Good. So picked everything up we needed. There's one number we haven't used yet. What number have we not used yet?
2.
Yeah, we haven't used that 001 yet. So I want this remainder to be less than 0.001, okay? Oh, but isn't there a better way to write 0.001 if I don't have a calculator? Remember we did this the other day? 1 over how many zeros? 3, right? So it's that, remember, we learned place value way back in elementary school, okay? We learned decimals in, I don't know, 3rd, 4th grade. That is the thousandths place is that 3rd one, okay? And so we rewrite it as 1 over 1,000. All right. Our goal now is to try to solve this, okay? We're going to probably have to do some guessing and checking, but let's get it in a form that's better to guess and check with, okay? I'm going to drop my absolute values because hopefully that's all coming out positive. I'm going to write this a little cleaner. It's like 3 to the n plus 1 over n plus 1 factorial less than 1,000. Sorry, 1 over 1,000. Okay. I don't think there's any, I'm looking at what we did. Oh, okay, we did make it in a better format. Okay. I could multiply this to the other side and multiply that to the other side, right? Or cross multiply. So I have 1,000 times 3 to the n plus 1 less than n plus 1 factorial.
Why is it not less than or equal to?
Oh, it should be less than or equal to. Thank you. I don't know why I have equal signs over here anymore. Those shouldn't be there. Okay. Only because 1,000 is a better number to look at. That's why I'm doing this manipulation here. Okay. It's just easier for us to see and play with in a calculator. Okay. If I was going to get the 1,000 by itself, I'm going to go ahead and move this back to the other side. So I'd have 1,000 less than or equal to n plus 1 factorial over 3 to the n plus 1. Okay, so what we're going to do is we're going to get out Desmos. Okay, and no, this would not be a good way to do this necessarily on the AP test. It's probably just these type of problems. Okay. But we're going to try to find a value, an n value that we can plug in there that gets us bigger than 1,000. Okay, so let's go into Desmos. Any version of it will be fine today. All right, and it was n plus 1 factorial. So let's see, what number do we want to start with? What n value? Give me any number. 5. Okay, so n plus 5, so n is 5 over 1 factorial. Divided by, I lost it already, 3 to the n plus 1. So 3 to the 5 plus 1. Ooh, need parentheses. 5 plus 1. All right. Did we get something over 1,000 yet? No. Okay, so what other number should we pick now? Give me another one. 10. There's 10. And we're going to put 10 here. Are we over 1,000 yet? Did we do better than 5, though? Yeah. Way better than what 5 gave us, right? Okay, so where should we go next? 30. Okay, so let's go 30. Am I over 1,000? Yeah. A lot, right? Because that means 19 places I have to move this. So I went way too big, right? It's okay, we had to know, right? So 10 was like 200 some. Where do we want to go next? 15. Okay, let's go to 15. See what 15 does. Cut it in half. All right, am I over 1,000? Do you think I could get closer, though? Yes. Okay, so we know we have to be somewhere between 10 and 15. What are we going to go next? 12. Okay, let's try 12. Ooh. That's a little better. 39. Let's see what the only other choice is 11, right? So let's try 11 and see if that works. Ooh, is it over 1,000? No, so what's our n value got to be? 12, right? So we guessed and checked it to 12. So here's what I would probably do we didn't write any of it down, right? You might want to write yourself a note. Because guess what? You're going to have to go back and do this and practice this in Delta Math, right? That we guessed and check using Desmos. Okay? And hopefully that will trigger your memory to do what we just did. Okay. Any questions on how we did that one? All right, I want you to read example 4 to yourself. So I'm going to give you an opportunity to read this time. Okay, it's asked in a weird way, right? So they gave me a 4th order approximation for E on the domain x less than 0.75, okay? So we know our x value cannot get bigger than 0.75. They gave us the E expansion. Great. Use Taylor's theorem to estimate the smallest possible upper bound of the error. Well, we know we've got to use the error-bound formula, right? That's what we got out of that last sentence. So let's start by writing that out. So we know our remainder, what's our degree? 4, okay, because it said fourth order, right? So remainder of sub 4 is less than or equal to, and then I got to do the formula, okay? What's supposed to go in the first part of the formula? No. The max. All right, what function are we working with here? E to the x. So I know I'm working with the function e, and this is a little bit different than we've done on the other ones, because I don't know, e doesn't like bounce between two places. It's a little bit harder to tell the max. Do I know the biggest x value that I could possibly have, though?
Yeah.
It's 0.75. Okay. All right. So I could do n plus 1, right, for my 4, or could I just do the n plus 1 part in my head? What's n plus 1? 5. So we're going to do 5 factorial, because that's 4 plus 1, right? And then in here I have to do x minus c. What's the biggest x value they gave me? What's the biggest x value they gave me? Because I have to do x minus c in here. 0.75, good. Let's see. Did they give me? Oh, look at your Taylor polynomial. We missed something. There's a typo. There was something missing. Did they give me a center?
No, they didn't.
No. Okay. It was supposed to be typed in there, centered at x equals 1. So add that in. That was my fault. Bad typing. All right, so what am I going to subtract based on that? 1. And then this would still be to the 5th power, our n minus 1 power.
Question.
Yes.
Does it matter if it's x minus c or c minus x?
Yes, because that does not have absolute value around it. And you might mess up your sign. Okay, does that make sense?
Yeah.
Which not a big deal if it's even, but if it's odd, it does. Okay, it's a good question though. All right, here's what I want you to do. Go ahead. Put that into Desmos. Figure out the smallest possible upper bound of the error. You can do the decimal point, that's fine. Okay, 0 point what? 0, 0. How many zeros? Tony, check and see what you look and see. Make sure you typed the right thing. Did you get the 5th power?
Because I got 4 zeros.
4 zeros and
172.
172.
Yeah.
Do we agree with Brooklyn?
Yeah. I never have
You left. I totally guessed. I'm like, what would be the mistake he would make? And it was I went with the 5th power just to see. Yeah.
Oh, and it's negative.
And it's negative.
Yeah.
It's supposed to be absolute value of it.
Oh, right. I didn't do that. Right.
So is it positive? Everybody good with the positive? We don't want negative. Usually error isn't negative, right? It would just be what's the error. Okay? Any questions on that one? It was kind of weird. All right, a little bit different. All right, these are all about just reading the weird stuff, right? Sometimes we just got to have a day like that where we're working on weird stuff. Good news, they gave us a graph this time. Wasn't that nice of them? All right. Read through the problem to yourself. What's wrong, Tony?
Is it Taylor polynomial the one where you can do the little like f derivative on side?
Yeah. So they did it for us, right?
Can you also do it for the other one, or the other formula? The little bar graph.
Yeah. Okay, so they gave us a Taylor polynomial, degree 3, right? They did it for us. They told us it was centered about x equals 0. So if it's centered about x equals 0, what's our special name? Is it?
McLaurin?
It's a Maclaurin polynomial, right? You could also pick that up because are they doing x minus c in there anywhere? No, they're just giving us x's, okay? So we know it's a Maclaurin. All right, we're supposed to use the information in the graph of f to the power of 4 of x. What is that really saying? What's that notation mean? What's this notation mean? That's the fourth derivative, right? So they're telling us this graph here is the graph of the fourth derivative. That's important because they gave us degree 3, and remember we do where our error comes from the first omitted term, or the first one, one that we skip. Okay. All right. And the Lagrange error bound to find the upper bound on p sub 3 of -2 minus f of -2. So remember, this is the actual minus the error is what they're talking about there. They just gave us a fancy thing for it. Okay. All right, it sounds like we've got to do the remainder formula again. So remainder sub 3, because it said degree 3, right, of x, is less than or equal to. All right, remember we're all about the first omitted term, right? So what we are looking at here, okay, this is the fourth derivative. And they wanted, let's go back and look at that formula one more time. Hold on. So I want to make sure I'm reading the formula right. It was the max of the derivative. Okay. So the value here, so we're actually looking for is the maximum value that that fourth derivative could possibly be. Okay. Maxes come from derivatives, right? So the maximum of the fourth would mean I'd have to look at the highest slope on that graph. That's not the slope of the graph, is it? The highest slope of the, so it looks like something's going on like here, right? So what would I'm looking at, I would look at this slope right here. See the slope triangle kind of created on that highest, like that highest steepness there? What are we thinking?
-3 or 8.
Yeah, it's like, it looks like an 8, doesn't it? Yeah. So if I kind of, so I had written down 8 last year, okay? That was a slope of 8, okay? So the highest it could possibly be would be 8. And we're not worried about negative positives, right? Okay. If 3 is my degree, what's my first omitted term? 4. So it's the n plus 1 would be 4 factorial. Okay. All right. What x value did they plug into this thing? Look here. Look for the clues. -2. Minus our c value. Brooklyn?
Yeah.
What's the c?
0.
0. There you go. Just trying to give you your moment. All right. And then my first omitted term was 4. Brooklyn's really good at the c value.
That's the only
You should not get that wrong on the quiz.
Why
Okay.
can't you get it wrong on the quiz?
Let's hope not. Okay. You should have the c value down. Okay. I will give you credit for the c value.
Awesome.
All right. So when we multiplied this, I didn't do the full answer, but when I try to get that equivalent here, I had 8, and then I wrote -2 to the 4th over 4 factorial is my answer. I was probably running out of time, so, which I'm not today. You guys want to put it in? Put it in your calculators. See what happens. Get the decimal. I don't know how Delta Math will leave the answer, so. Okay, what do we get?
5.3.
5.3
repeating.
repeating. Okay. They might stop it here, so just be ready for that. Maybe try putting that in. If that doesn't work, then go to your decimal maybe. Okay. I've tried to up the attempts in Delta Math a whole bunch this year. I've given them like 5 or 6 attempts so that you don't have to keep redoing a million times. Okay. Any questions on 5? 6 is kind of similar, except they didn't give us the graph. So read 6 to yourself. Okay. What is the degree that they're giving us here? 5. Okay, so we're looking for our remainder of our 5th degree polynomial. Okay. Here's what I want you to do. Okay. I want you to go through the formula, right? Remember, you've got to find the max. They gave it to you. It looks different this time. I want you to find your max value, put it there. Okay, your x minus c to the n plus 1 over n plus 1. See how much you can fill in. It's okay if you make a mistake, all right? See, just looking at that and what we know, see if you can fill it in. I think you can. You've done enough. Okay, what do we think the max is? Oh, good job. We recognized it right here, right? They gave it to us. The one beyond, right? The 6th derivative that says it's going to be no bigger than 10. Okay, I like that version of it, right? We didn't have to guess. We didn't have to look at a weird slope. We didn't have to do any of that business. They were very explicit about it. All right, what was the x value we had to plug in? Yep, it was hiding right here, right? All right, minus was my center. -5, right? Because they told us here. Okay. And then it was to what power? Okay, I heard 6 and I heard 7. What's the n value, or what's the n value we're actually working with? 5. So my first omitted term would be 6, or n plus 1, right? 5 plus 1. So it'd be 6 there and 6 factorial there. Did anybody go for the decimal? If you didn't, it's okay. All right. What I wrote down last year was 10 times 0.5 to the 6th power over 6 factorial. Because negative 4.5 and 5 is 0.5. Okay. If you guys get the decimal, great. That's okay. If not, I'm good. I want to look at this, and I want to give me a second. Well, if you want to mess with that decimal, you can. I'm gonna go. I gotta switch to a different answer sheet here because I never did the other problem last year, so I got to go to the place where I have it. Okay. Let's take. Oh, it looks like Delta Math's leaving the answers. Oh, they're doing something else. Okay. So I'm looking at the Delta Math version of the answers. They're leaving an absolute value around this for some reason. So same thing on this one. So they didn't go to the decimal on this one either. So we'll need to just make that adjustment. Okay. I don't know why they moved their absolute values in, but that's how they're typing their answers. It has no difference in what we did. Okay. Let's take a look at example 7. Go ahead and read it to yourself because you know the College Board loves a good table. Okay, let's do this problem and then I'll have you go, okay? I won't take that. Actually, no, you're gonna have to go now because if not, they're gonna close it off. Let's do it. All right, what's your ID?
160579.
Okay, go ahead, Connor. Okay, let's take a look. You know, College Board loves a good table. Okay. Again, we have all the parts. It's talking about us finding the Lagrange error bound, like they were very specific about that. So I know I'm going to have to dig out that formula. So let's dig out the formula. So absolute value of the remainder, what is the degree? 2. It says it right here, right? So degree 2 is less than or equal to, okay? We got to find the max value. So the maximum value, what the value could be of which derivative? We got to go one beyond. It says we're degree 2, so we got to go to the third. Look at the max value in the table. 28. Okay. All right. They put their absolute values, so they didn't do the absolute values like the formula did. They did their absolute values in delta math around this piece, around that x minus c piece. All right, what's the x value?
Negative 4.3.
Good, negative 4.3 minus, where are we centered?
Negative 4.
Yeah, so minus negative 4 from right here, right? So this was the x, this is the c. All right, to the what power? Third, good, 1 beyond. If you need to write the 2 plus 1, you can do that, and then all over 3 factorial. The only other thing they did on this was they did 28 minus 0.3, oops, absolute value bar, cubed over 3 factorial. Okay. It's all about just looking for the numbers for the formula in the problem and plugging them in. Okay? The good news is this might be one question on the AP test.
It's like full set of notes.
Yeah. We're at that point where there's some things that'll just be one question. The better news is if I remember right, the ratio test comes back tomorrow. Is it? Let me see. I'm looking. Does it come? Oh, yeah, the ratio test comes back. It's going to be a good Friday and probably Monday too, because it probably won't take, it'll probably take us till Monday to get them all done. All right, that's it for today. I think I put the